All right, moving on to section 1.5 on describing angle pair relationships. So section 1.5, how can you describe and identify different angle pair relationships? We're going to start out with complementary angles. These are two angles whose sum is 90. And just recall that the word sum means when you add them up, they will add up to 90. So one example of complementary angles would be, whoops, let me change back here. Would be if you have one angle that measures 40 degrees and you have a second angle that measures 50 degrees. Those would be complementary because 40 plus 50 is 90. Okay. Supplementary angles are two angles that add up to 180. So, for example, if we have one angle that's 150, we have one angle that's 30, 150 plus 30 is 180, so those two angles would be supplementary. Adjacent angles are two angles that share a common vertex and a common side. So to be adjacent, we would have two angles. We'll call this angle 1 and this one angle 2. Notice that they share a vertex and they share a side. So we would say angle 1 and angle 2 are adjacent. All right, and then a linear pair. A linear pair is two angles whose non-common side are opposite rays. So in other words, linear pair forms a line. So it'd be if we have a line and the angles look like this. We'll call this 3 and 4. So notice they share a side. Angle 3 and angle 4 still share that side, but they have opposite rays. The green and the blue are opposite rays. So angle 3 and angle 4 are a linear pair. And then lastly, vertical angles. Vertical angles are two angles whose sides form two pairs of opposite rays. So I think the easiest way to draw vertical angles is by just drawing two lines. So we'd say angle 5 and angle 6 are vertical angles. I'm going to change colors. Angle 7 and angle 8 are also vertical angles. So there's two pairs of vertical angles when two lines cross, the green pair and the red pair. So vertical angles are just two lines that cross each other, and the angles that are across from each other form the vertical angles. Okay. Example 1 says, identify complements and supplements. In the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So which angles are complementary, or which angles add up to 90? Looks like 52 and 38 would be the ones we have. So it would be angle B, and this other angle will be called angle BDC. Because angle B is 52 degrees, and angle BDC is 38 degrees. So when you add them up, they add up to 90. Supplementary angles, 52, and then the one that's 128. So the supplementary angles would be angle B, and this other one would be angle EDB. Again, because angle B is 52 degrees, angle EDB is 128 degrees. When you add them up, you'll get 180. And lastly, name a pair of adjacent angles. Adjacent angles are angles that are touching. So if you look at the picture, this yellow angle and the green angle are touching. So it'd be angle CDB and angle EDB. Those would be the adjacent angles because they share a side. You see how the yellow and the green are overlapping? So those would be the adjacent angles. Example 2. Find the measures of complements and supplements. So if we're given that angle 1 is a complement of angle 2, what this means is that those two will add up to 90. So angle 1 is a complement of angle 2 means the measure of angle 1 plus the measure of angle 2 equals 90 degrees. So angle 1, we don't know. It says find angle 1, but we do know angle 2 is 57. So we'll put 57 degrees, and we still have to find the measure of angle 1. So how do you get measure of angle 1 alone? Since they're complements, they add 90, so we have to get rid of that plus 57. Cancel that out. So the measure of angle 1 is equal to 90 minus 57, which is 33 degrees. Part B, given that angle 3 is a supplement of angle 4, so stop there. Supplement means adds up to 180. So we would say the measure of angle 3 plus the measure of angle 4 equals 180 degrees. They tell us the measure of angle 4 is 41. So I'm going to put 41 degrees below there. We're trying to find the measure of angle 3. So the measure of angle 3 plus 41 degrees equals 180. So if you minus 41, you end up with the measure of angle 3 equals 180 minus 41 is 139. So the measure of angle 3 is 139 degrees. Then there's a couple checkpoints that we can run through quickly. Complementary angles would be angles add to 180. So it would be the two blue angles. So angle DEF and angle B. Because 50 degrees plus 40 degrees is 90 degrees. Supplementary would be angles that add to 180. The two green angles. This would be angle GEF and angle B. Because angle GEF is 140 degrees and angle B is 40. 140 plus 40 is 180 degrees. And then adjacent angles are angles that are sharing a side. So notice that the 50 degree angle and the 140 degree angle, this yellow angle and the green angle share a side. So we would say angle D, E, F, and angle G, E, F. Those are adjacent angles. And angle B is not adjacent to them because it's off the side and it's not sharing the side. Number 2, given that angle 1 is a complement of angle 2, that means the measure of angle 1 plus the measure of angle 2 equals 90 because they're complements. If the measure of angle 1 is 73 degrees, we're trying to find angle 2. So it would be 73 degrees plus measure of angle 2 equals 90. How do you get the measure of angle 2 alone? you have to get rid of that 73, the plus 73. So that'll cancel. So we end up with measure of angle 2 equals 90 minus 73. The measure of angle 2 equals 17. And then checkpoint 3. If 3 and 4 are supplements, that means that when you add them up, they're going to add up to 180. And the measure of angle 4 is 37. So measure of angle 3 plus 37 degrees equals 180. Find the measure of angle 3. So to get angle 3 alone, you would subtract 37. And we end up with the measure of angle 3 equals 180 minus 37. 180 minus 37, we would get 143. Okay, and then we have a couple more examples. We're going to skip some checkpoints here. The basketball hoop one. The basketball pole forms a pair of supplementary angles with the ground. They also form a linear pair. Notice that they form a straight line. So what we want to do is find the measure of angle BCA and the measure of angle DCA. So these two angles form a line and they're supplementary, which means they must add up to 180. So that means this side and this side add up to 180. So 3x plus 8 plus 4x minus 3 equals 180. Okay. On the left side of the equal sign, we're going to combine everything we can. So we have a 3x and a 4x. Put those together, you would get 7x. We have an 8 minus 3. 8 minus 3 is positive 5. Now we're trying to get x alone. So you have to get rid of the plus 5. And it's 7x equals 175. And lastly, divide by 7. X equals 175 divided by 7 is 25. So I want to kind of put a cloud around this because I'm not done. The directions say to find the measure of these two angles. So if you want to find the measure of those two angles, you have to plug in x. So we want to find the measure of angle BCA. Oh, we got to get rid of that. I want the pen. Measure of angle BCA is 3x plus 8. That would be 3 times 25 plus 8. Three times 25 is 75. So it'd be 75 plus 8. And I know I'm going fast. I apologize, I'm going too fast for you. So we are plugging in 25 in for x. So 3 times 25 plus 8. So we end up with the measure of angle BCA equals 83 degrees. And if you want to find the measure of angle DCA, DCA is 4x minus 3. X is 25, so we're going to put a 25 in for the x. So the measure of angle DCA is 4 times 25 minus 3. 4 times 25 is 100. 100 minus 3 is 97. So we get 97 degrees. And if you look, 97 plus 83 adds up to 180. And that's what we wanted. Okay, so we have checkpoint 4 and then example 5. So we look at checkpoint 4. Suppose the angle measures are 5x plus 1 and 6x plus 3. So we have 5x plus 1, 6x plus 3. And we want to find the measure of angle BCA and DCA. So again, these form a straight line, so which means they add up to 180. So you would take each part, 5x plus 1, you would add 6x plus 3, and since they form a straight line, they would add to 180. Okay. On the left side of the equal sign, you would combine 5x and 6x to get 11x, and 3 plus 1 is 4. And then you would minus 4 to get 11x equals 176. Then divide by 11. 176 divided by 11 is 16. So you'd find x, and then you would plug it in. So the first angle, measure of angle BCA, would be 5 times 16 plus 1. And 5 times 16 plus 1 is 81 degrees. And again, I'm putting 16 in for x here and in for x there. So the measure of angle DCA is 6 times 16 plus 3. Six times 16 plus 3 is 99 degrees. And we have a couple examples, and that's going to be it for the day. So example 4, identify all the linear pairs and all of the vertical angles. So the linear pairs are all the ones that form a line. So we can start by highlighting a line. So there's a line right here. So which two angles form that line? Angle 2 and angle 1. So angle 2 and angle 1 are a linear pair. Okay, and we could say 3, 4, 5, but that's not a pair then. 3, 4, 5 is actually 3 of them. So the only linear pair that forms that blue line is angle 1 and angle 2. There's a second line going straight up and down. And which two angles form that line? Angle 2 and angle 3. So the second linear pair is angle 2 and angle 3. So there's two different pairs of linear pairs. Vertical angles. I don't know why I can't erase that, but vertical angles are angles that are across from each other. So actually, if you look at the blue X that's kind of formed here, angles that are across from each other form vertical angles. So in this case, it would be angle 1 and angle 3. Those are vertical angles because the two lines cross, and those are two angles across from each other. And we can't say 2 and 5 because 5 is kind of part of this angle. You see how 5 does not cover the whole thing, so we can't say 2 and 5. So the only vertical angles are 1 and 3. And I'm going to show the checkpoint just so we have a better understanding of this. So linear pairs. So if we first use red, is there a pair of angles that form that line? There is no pair. There's actually 3 on the top and 3 on the bottom, so that doesn't work. What about, is there 2 angles that can form the green line? And if you look, there's angle 2, 3, and 4, but that doesn't count because because they don't, there's more than one pair. And then lastly, this yellow line, there's more than one angle that forms it. So if I use a yellow highlighter, do you see how there's 2, 1, and 6? That's not a pair. 2, 1, and 6 is actually 3 of them. So that doesn't work either. So I need to erase this. Let me see if I can. I guess I can't erase that part. And then so we would say none. Sorry. Either a linear pair, there's none, because no two angles form a line. And then the vertical angles, there's actually 3 of them. So with the yellow and green one, there's angle 2 and angle 5. Right? With the red and green, there's angle 1 and angle 4. And then with the yellow and red, there's angle 3 and angle 6. So there's actually 3 pairs, the yellow, the red, and the blue. Okay. I think we're on to our last example. Find the angle measures in a linear pair. So 2 angles form a linear pair. This means they add up to 180. The measure of one angle is 4 times the measure of the other. Find the measure of each angle. So what we have is we have the first angle and the second angle. So if we don't know the first angle, what do we call it in math if we don't know something? If we don't know something in math, we usually call it x. So the first angle is x. We don't know if it's 5, 10, 20, 80. We're going to call it x. What we do know is that the second angle is 4 times the measure of the first, or the other angle is 4 times the measure. So if the first angle is x, what's 4 times that? 4 times the measure is going to be 4x. So the angles we're going to call are x and 4x. So 2 angles form a linear pair. That would be x and 4x form the linear pair, which means they add up to 180. So x plus 4x is 5x. And then divide by 5, because we want to find x. X equals 180 divided by 5 is 36. So we want to find out how big are the 2 angles. Well, the first angle is x, so the first angle is 36 degrees. The second angle is 4x, so it's 4 times 36 degrees, which is 144 degrees. So the 2 angles are 36 and 144. And I will do the checkpoint just so we can see one more example of this. So 2 angles form a linear pair. The measure of one angle is 3 times the measure of the other. So we have angle 1, we'll call it angle 1, and we'll call it angle 2. So we don't know what angle 1 is, so we'll call it x. But we do know that one of the angles is 3 times as big as the other. So if one angle is x, the other angle is 3 times as big. So we're going to call the 2 angles x and 3x. They form a linear pair, so that means that x plus 3x adds up to 180, because a linear pair adds to 180. 4x equals 180, and then we divide by 4 to get x equals, I believe it's going to be 45, yes. So x is 45 degrees. If we go back, that means angle 1 is 45 degrees. And angle 2 is 3 times 45 degrees. So 3 times 45 is 135. So those will be our 2 angles. And that's all we got for today.